In this video, I'm going to talk about 5 ways to share data between your services in a service-oriented architecture. There are 5 ways that I'm going to talk about today. They are shared database, remote procedure call, file exchange, data aggregator, and messaging. And I'm going to go through some pros and cons of each. If you want to share a database, there's a very high likelihood that you already have a database in your infrastructure, so you won't have to create a new one. It's very likely compatible with every other technology that you could choose in your enterprise or in your application. It will be compatible with your reporting server. It'll be compatible with legacy applications. It'll be compatible with the brand new thing, new language that you want to try. And all you need to do is make sure that you have the table schema available to the service. And backwards and forwards compatibility is really easy to achieve. You can put defaults on fields, and you can leave them blank or null if you need to. And if you have fields that your application doesn't know about, well, they're easy to ignore. But, and this is like, tell me I'm wrong, you will feel dirty and like a sellout if you use this to communicate between your different services. And I think that's sort of summarized by the next point, and that's that you've accidentally created a contract and it's a bit wishy-washy, a little bit loose, and now you've got this contract with the database, which you're now going to have to change control. But sometimes this is a really good solution. It's really easy to get up and running, and you could think of those 2 extra points at the end as technical debt. You could create a remote procedure call. This involves putting an endpoint on one of your services, and the other service calls into that service. It goes onto the wire, and it comes back once it's done, which basically means you get time to results. You basically know the answer to the question or query or command or whatever it is that you've invoked as soon as it's done. You can control the contracts, which is something that's different to how we talked about with the shared database. And there are lots of different options for the transport. So you could use JSON, SOAP, you could use XML over HTTP, you could use protobufs, or you could make up your own protocol. And there's some old school ones as well. You could use DCOM or Corba, lots of options. And the world's your oyster. But some things that you need to consider are latency and networking issues, in particular if your services are far apart. You might need to cross network boundaries, and that involves security and encryption and stuff like that you will have to take care of. You can't get away if you want to control the contracts, you can't get away from change management. So sometimes that can look like versioning. So you offer one version of your contract, and then at a slightly different endpoint, you offer a different version, and you call them out by version ID so that the caller knows which version that they care about. Or you could make sure that everybody upgrades at the same time. So now you've created dependencies. But that's okay. I think that you can use your judgment when deciding whether or not you need to be really strict about versioning. One thing that you've done here, though, is that you've created a dependency. And when you do that, well, your uptime will affect your caller's SLA. So if they have a service level agreement with some of their customers and they're calling into your service via a remote procedure call, and your service has an outage, well, then they have an outage too. So something to consider. It may mean that you need to now support extra uptime so that your clients can guarantee their service levels. And I talked briefly about security concerns. File exchange is old school. It's even older school than sharing a database. But there are some advantages of doing things this way. You don't have to have services that run all the time, which that can really save you money. You can, if you just spin up a batch job and perform all of the work, once or twice a day, especially if you don't have to do that frequently, bulk processing is a realistic option now if you use File Exchange. When to run, obviously if you are doing this once or twice a day, you need to make sure that it will finish before the next run. Batch processing leads to delays, and that might be tolerable for your particular use case, in which case, File Exchange is totally fine. You will need to grant access to a file server, and you'll need to, there are different options that you can use for this, FTP, SFTP. You might still expose an API and dump a file on the file server whenever an API is called. That's an option too. And yeah, if you have a file server that you need customers or different servers to access, well, you need to deal with passwords, and that's always a hassle. And one thing that you really shouldn't do is process a batch of data without being very careful about what's in it. You need to make sure that you've got valid data. And I guess that's the same for all of these mechanisms, but in particular, File Exchange, where the customer is giving you a file, you need to make sure that they've given you something that's well formed. Moving on. A data aggregator is really just remote procedure calls, but with extra remote procedure calls inside of it. What it does is it allows you to protect and wrap your contracts and get sort of disparate data together and present an API to your client or to your other service, so that it doesn't have to think about getting that data together. And that might be an advantage, particularly if you've got several services that are running on the same host. You don't really have to worry about latency in that circumstance. You're just thinking about serialization. So the problems with this are dependencies. You've got extra latency potentially, particular if you're running on a separate host. You've got the serialization overhead, which would be different to as if you had just put the API inside of the service. That might not be an option to you, particularly if you're on a different team or in a different company and you don't own the service that you're aggregating, and that's totally fine. And it basically just means that more services are required in your call graph for a call to succeed. And the final and probably the most popular and vogue way of doing this is via messaging. One nice thing about messaging is that you don't have to wait for processing to finish, and that means that you might be able to improve your throughput. That's debatable. You like API calls, you can control your contract, and there's an ability to scale because you can separate the things that are performing the message from the message handling as well. It does have the same drawback in some ways as the batch processing or the file exchange, and that's that you will introduce delays potentially. In addition to that, you also need to worry about delivery order. And you could say to me, Phil, I'm just going to process all of my messages in order. Well, I don't believe you, partly because you will want to try and scale, partly because you'll have errors and you want to retry. And if you retry, it means that you're delivering messages the second time out of order. The world's just not easy. Sometimes things get lost in the post, and there's no, depending on what you choose, you might actually get a guarantee of an order delivery. You probably need to monitor your messaging. Ideally, you would know if a message had gone into a service and failed. And one final thing about this is that, putting messaging into a system basically increases its complexity. And that's partly because you don't have the nice normal call graph. You basically have to suspend and wake up every process that deals with a message. Even if it's a response, it may be a response to a calling application, but that calling application has gone out of memory and is now a new process altogether. So it still needs to be able to respond to the messages, though it had been the original invoker. All right, so those are the 5 different mechanisms that I'm going to talk about today. Did you like this? I'd love to hear what you think. Let me know by email, Twitter, Threads, or you can follow me on GitHub, or you can just like and comment, or dislike and put an angry comment there. That's fine. I'd love to hear your feedback. Let me know. Talk to you next time.